active power that the plant consumes. So imagine now that you say, all right, Eric, I want to reduce my maximum demand, and we install a panel of 67 kilovars. So that means that the PFC panel supplies 67 and Eskom still supplies 33. So as far as Eskom is concerned, we've taken this down like this. So by supplying 67 kilovars, we reduce the apparent power drawn from Eskom to 105 kVA. So that's a saving of 37 kVA.
So the demo unit that we looked at earlier, or the demo unit in the other video, showed us 3 steps. So what the demo unit would actually be measuring is, it would be measuring what the KVAR is in order to determine which step to activate.
Yeah. So the 67 would be broken up in 3 or 4 blocks. 20, 20, and 27 for argument's sake.
Okay, that makes sense.
Because this is not going to stay constant. As motors get switched on and off, or motors get more loaded or whatever, this is constantly changing.
So it's important to have a power factor correction unit that can measure and implement steps automatically.
They all do, no matter what make. Yeah, they all do. Yeah, that's the minimum requirement.
Okay, and they're all automatically selected. Okay.
Absolutely. We'll come back to this triangle a bit later, because there's another issue that we need to explain. Right. So what are the benefits of power factor correction? Well, obviously we reduce the apparent power, like I showed you, by putting, in that particular case, a power factor correction of 67 kilovars. We reduce the apparent power drawn from Eskom by 37 kVA in this particular example. Obviously, we lower the electricity bill. We also increase system capacity. We see that often in businesses where, especially successful businesses, they have a 1 MVA supply, and initially when they set up the factory, they had a load of 500 kVA, and then they add another machine, and they add another machine, and more and more and more. And at some point, they fully used up the available power. So, as you can see, if you have how would I say now? So go back to that other example that we had, where the transformer, where the load was 142 kVA. Say that they had a 150 kVA transformer. They were very close to the limit. By dropping it to 105 kVA, now suddenly the customer can add more machines without upgrading his supply. And that often is ginormous savings, because the investment of an upgrade is ridiculous, because it's your MV supply that needs to change, your transformer needs to change, your distribution panel needs to change, because the bus bars will be underrated, the main breaker will be underrated, so all that stuff. So then the savings are basically based on the profit that the customer is going to make by being able to install that additional machine without an expensive upgrade of the electrical supply.
No, that's interesting.
So we call that capacity, freeing up capacity. Obviously, voltage can improve as well. If a transformer is heavily loaded, obviously you will have heat losses in the cables, in the transformer. So by unloading, by putting a power factor correction panel, there's less load coming through the transformer and through the supply cables. So all those losses are eliminated. And obviously the losses also result in a voltage drop. So you reduce the heat losses or the watt losses in the transformer and the cables, and you you improve the voltage. So that's in situations where it's the load is so big that the actual volt drop is massive. Okay, we spoke about reduced transmission losses. And then automatic power factor correction panels are usually the way to go. What I'm trying to say is that you can also install capacitors directly on motors. That is applicable in very specific situations. We've done that with farmers or something like that, where the guy's got like a 100 kVA transformer supplying him, and he's got a massive borehole feeding a holding dam, and from the dam there's a pump feeding a center pivot. So there's only a few very large loads. In that particular instance, it's actually better to put capacitors, rightly sized capacitors, directly on the motor, so that the reactive power that the motor uses is manufactured at the motor. So, but in most instances, an automatic system is the cheapest way to go. So, how do you size this? Well, there's two ways. I like to say, if